Namaskar, welcome to Prakash on Basics. I am Prakash Zog and we are looking into vision. There is a lot more to the eye than just seeing. Let us try and look into the beauty of its variety of functions. We will start with a few of them. First, realize that there is a vast range of things that an eye can do, and that is basically because of two factors. One, the way the eyes are designed, special system, and then the adaptability of the eye to different situations and conditions. In fact, sometimes the delay in the adaptability itself is an advantage, and that also is something that we will look into. Let me remind you of how we see things. Realize that eye is a marvel of evolution, and the way in which we see has a systematic sequence by which things happen. Light falls on an object, the object then creates an image on our retina because of the cornea, the lens, the pupil and the iris that is in between. The cornea itself has multiple layers. The topmost layer, which is of rods and cones, results into sensing this particular image either in terms of intensity or in terms of color. And then there is a bundle of nerve cells behind, typically known as ganglions, which link everything, all information to the optic nerve. The optic nerve actually breaks up the information into 4 subparts. 2 of them cross over and 2 continue as they are. That happens in a region known as the chiasma, and then from there all this information goes to the occipital lobe in the brain. Then it is rearranged and sent into the midbrain, which actually controls quite a few of the motor functions of the eye, like how to turn it around or how the ciliary muscles function and all this, how the iris opens and closes. And that's the general way in which the image formation takes place. I have just given you the path. It's not essential that you remember every step along the path, but you should know what really happens. The eyes clearly see objects even if they are near or they are far away, and that is the first property that we will talk of. Accommodation is the ability, accommodation of the eye obviously is the ability of the visual system, everything, to adjust itself to see things properly, clearly, even at different distances. So now we are talking in terms of distances. In order to see properly, the corona, the lens, the pupil must suitably adjust themselves so that a clear image is formed on the retina, and the retina must then sense this image correctly. To see distant objects, the eyes can accommodate to a maximum distance limit, and that is said to be the far point of accommodation. Mathematically, by the laws of lenses, how images are formed, this distance should ideally be infinity. But practically, for normal human beings, this distance is 6 meters in MKS and 20 feet if we talk in terms of the feet FPS system. The reason, of course, is that from 6 meters to infinity, the amount of changes that need to be brought about in the eye are practically negligible. So the maximum clarity that we can see nicely for an object for normal human beings is 6 meters. And therefore, as I will discuss maybe next time or time after that, the way in which eye testing is done for a maximum distance of 6 meters or 20 feet. If there is a distant value, then there also has to be a near value. The lower limit of accommodation must also be known. That lets us see clearly objects that are closest to, for normal human beings, around 11 centimeters or around 4.3 inches. Typically this has to be with both the eyes, and this is known as the near point of accommodation. So I can look at an object that is far away, or I can look at an object like my finger and see the way in which things change as I try and concentrate, and beyond a certain limit I can't see the finger very clearly. That limit is roughly around, as I said, 11 centimeters. Normal people can see things between these two values, the near point and the far point. But how does this happen, and how do things adjust? The shape of the lens can be changed by using what are known as ciliary muscles that are around the lens inside. They are attached to the lens. This change is very rapid and takes place in less than 1/4 of a second. Simultaneously, the pupil inside also can dilate or come down to a smaller size. That also is very rapid. To see any object that is far away, the lens has to be made flat. So it has to be thinned out like this, and its curvature has to be reduced. And when you bring your finger close, the lens has to become thick and adjust itself so that the image precisely falls on the retina. So the bulging shape is when we are trying to look at objects that are very close. Please also realize that it's not only one eye that matters, and the response is of both the eyes together. And this is the speciality, because the information is coming from inside the midbrain to both the eyes simultaneously, irrespective of where the information is reaching as far as the eyes are concerned. The control of the muscles, either to turn things around as I move my eyes, or to open or close, I can't do it for one eye. It is all controlled and synchronized properly from the midbrain. And the motion need not always be in one direction. When I start looking at my finger, you will find that both the eyes now move inwards, and the direction of movement is opposite to each other. And immediately if I start looking at an object that is far away, both the eyes start moving in opposite direction. But if an object is moving across my field of view, then both the eyes will move along with the object, tracking it down. So all these synchronized movements are controlled by the midbrain, and that is the region where the optic information is interpreted and controlled. Together both the pupils will dilate, together both of them will shrink, both will move together, and so forth. The eyeballs will respond together in a suitably coordinated manner. Realize that it is the modification of shape of the lens and the adjustment of the eyes that converge at a particular point, and a slight shift in the position of the lens. This is something that we don't sense, but it does happen. The lens also adjusts itself to a small extent. The eyeball itself adjusts itself to a small extent. The cornea also adjusts itself to a small extent when we try and look at an object that is very close. You will also realize that all this puts a bit of a strain on your eyes. So where do we see things that are very clear? And that distance, as I told you some time back, is known as distance of distinct vision. At around 10 inches or 25 centimeters, things that we see are very clear, sharpest, because the image has been formed on the forever, and the clarity, the colors, the details are all to their upper limit or maximum. So this is what accommodation of the eye talks about. We need to talk of the ability of the eye to respond to one more factor, and this is known as adaptation. It is the way in which both our pupils and lenses and the eyeballs inside, along with the retina, respond to changes in the intensity of light. An advanced state that we are in is only in the last 10,000 years. Humans have been around for more than 2 lakh years, and the vertebrates which we are a part of has been for ages together, and we have been doing all these adjustments to our eyes right from that time. And there, the change in the intensity of light is because of day and night and other conditions. What happens obviously is the sunlight, the direct sunlight that comes, the dark at midnight, the cloudy natures, the way we walk into caves and see dark spaces around, and then our eyes are expected to see clearly under all these conditions. And this is the adaptability of the eye. Please realize that whenever we adjust to the intensity of light, there could be adjustment that is associated with temporary change in the intensity of light, or it could be a long-term change in the intensity of light. Suddenly the brightness changes, or the clouds come over, or there is a spark somewhere, or there is a lightning, and then it disappears. This is all a temporary change. Or when you are looking at an object where there is a patch of sunlight, and then you are shifting your eyes to the other side. In such cases, the adjustment basically is associated with the change in the size of the pupil. It is the iris whose muscles are controlled, and the opening is increased or decreased. So when you want more light or it is dark, immediately our pupils dilate and take in more amount of light, and when it is sudden bright spot, you tend to reduce the opening, and the pupil constricts because of the muscles in the iris. And it's a very fast process, as I said, less than 1/4 of a second is the time in which all this happens. Usually all these times are measured in milliseconds. But sometimes the situation is such that you want to respond very rapidly, and then you try to overcompensate, and when you try to do that, there is a limit to the change in the iris size. So you try to control light by using your eyelids. So you reduce the size of the opening of your eyelids, or you dilate your eye, you extrude your eyes outwards as such, and try to open out as much as possible. Please realize that this also happens when there is a scare or a threat, and that is because at that instant, this is known as typically known as the fear and flight mode, more for animals who are being prey and others. Now all such situations, the idea is to gather more amount of information, and to do that the aperture has to be large, so that more light goes in, you get more amount of information. And so when there is a scare, you tend to open your eyes wider, because there is a limit to the iris opening. So this process of adaptation is not only associated with the intensity of light, but also associated to a small state, to the physical state and the psychological state that we are in. Now this is one situation. Let us look at the second possibility, and that is equally important, and that deals with the situation which deals with a change in light for a longer time span. I'll typically give you a situation. Let's say you go to see a film, and you are very systematic in your approaches, so you land up about 10-15 minutes early, and you go and sit down inside, and there are 8 or 10 people sitting next to you, and the whole theater goes dark, and you're just talking to each other, and after about 10-15 minutes some people land up a little late, and you will realize that the instant that they walk in, they are practically blind. Somebody has to lead them in. They keep typically falling around and trying to hold on to others and so forth, and try to get into their proper seats. And if you look at them, you can see them very clearly, and you are wondering as to why they are acting like blind people. And in fact, if the situation is reversed, you would have been practically doing the same thing. The instant you move from a very bright light into a dark space, you are practically blind for some time. This needs some time for you to start looking around and seeing things, and that time span is close to around 20 to 30 minutes, and that time span deals with the next step of adaptation to light. So adaptation to light could be of two types. When you move from bright light to a dark situation, or a reverse case when you are moving from dark to light. So there could be light adaptation or dark adaptation of our eyes, and in both these cases there is a change which is a biochemical change, which is far more than controlling that iris that we have been talking about. And what happens then is equally important and interesting. To understand this, we must look into one more aspect. How do rods and cones behave? Realize that the rods, which are associated with the intensity of light, have a certain limit up to which they can sense light. Such limits are typically referred to as thresholds, and the threshold of the sensitivity of rods is pretty low. So even in dark you are going to see because of rods. The cones, which respond to colored light or to different wavelengths, has a higher threshold. So for you to start seeing using cones, you need higher intensity of light. So in the dark it is the rods that function effectively, and in bright light it is the cones that are more effective to light. One more thing is important. and that is associated with that chemical that I did mention some time back. It is known as rhodopsin, vitamin A, retinal and all that. All that is finally boils down to the same thing. When there is, let's look at it from 2 or 3 different steps first. When you are in bright light, light is entering, sufficiently strong light is entering into your eye, and because of it, the rhodopsin in our rods gets overexposed to radiation and it gets bleached. So the response of the rods decreases. They tend to slow down. They respond very rarely. But the threshold level is pretty good for the cones to function. So the cones begin to function in bright light, and then they can sense all the light and they can sense the colors and the images formed, and you see and you observe things and you sense the colors, and all that is because of the rods less, cones far more. And this is what happens in bright light. It is because rhodopsin has been bleached and cannot respond to the same extent as expected, while the other pigments and chemicals in the cones are effective enough. Think of the reverse case. When you move into the dark situation, the intensity of light drops. As it goes lower and lower and lower, below a certain point the cones cannot function. So the cones will slow down. Now the rods are already bleached, the cones also have stopped functioning, and so you cannot see anything. So suddenly when you move from a bright spot into a dark region, you cannot see anything. But gradually this rhodopsin starts coming back from its bleached state to its normal state. The effect is obvious. The rods begin to function, and if the rods begin to function, you start seeing things around, and this rhodopsin coming back to its unbleached state takes about 20 to 30 minutes. So after around 20 to 30 minutes, you start seeing things properly even in dark, and that's something that all of us have experienced. We realize that if you're at night, if you go to sleep, when you get up at night, suddenly if you're awake and there are no lights around, you can still see quite a few things. Or at night you start seeing things pretty good after 15 or 20 minutes. Typically this is known as night vision. On the other hand, see what happens when you do the opposite. When you suddenly move from dark to a bright place, inside the pupils are already dilated. The instant you come out, all that light goes on your retina. The rods are exposed to bright light. Rhodopsin gets bleached and it stops functioning. But now that the light intensity is good enough, the cones begin to take over, and they start seeing around all those colors and beautiful things that are around. The instant you come out in this bright light, because the intensity is too strong, you tend to close your eyes, it becomes too bright for you. But gradually, in a time span of about 5 to 10 minutes, you have readjusted yourself to this new situation of bright light, and it is the cones that now function more effectively, taking care of all the vision that you see around. So this is how we have adaptation to light when you move from bright to dark and from dark to bright. But there is one more aspect. I walk into a theater and I see a film that is being projected and I see all colors. That is because that time the brightness of the picture there is good enough for your cones to function, and so the image formed on the retina causes the cones to respond to those particular colors, and you can still see that picture sufficiently nicely and clearly with all its colors, even if everything around is dark. Realize that if you have been staring at such a good film, a person running around or some beautiful situation, and you drop something, and if you try to look down at your feet which are in dark area, you can hardly see anything, because again the same thing has happened. The intensity of light down is too low for the system to react, and your night vision has been lost. Please realize that any bright event, even temporarily, can reduce your night vision, and that becomes very important at 2 or 3 different places that we know of. The first, of course, is all those who know about ships know that at night it's extremely dark at sea, and so the pilots and the captain and the other people have to be specially adapted to looking around, watching out for things, and so they have to adjust themselves to night vision. Adjusting to night vision takes about 20 minutes of time, half an hour's time, and they remain in an area on the bridge facing the sea, looking out for things with night vision. One more aspect: if temporarily somebody switches on a light in the room, this night vision level suddenly drops. Though the amount of recovery time is, if it is switched off immediately, the recovery time is much faster than the previous 20 minutes. And for this, there is another technique that was adapted. That must also be known. Pilots specifically, for all these special Sukhoi and others, many of them are given red goggles to wear, which cover their eyes completely for the flight. The reason is very simple. Red light means long wavelength. Long wavelength means less energy, and so red light is not enough to bleach the rhodopsin. So the rhodopsin is unbleached if you are using red goggles, and so then if you suddenly shift over to a dark area, take off in a flight at night and start looking around, then your ability to adapt to the light in dark is much faster, and so using red goggles helps in trying to adapt to this light condition much faster. There is one more issue that I must mention, because it is related to what we are talking of, and that is what happens when you look at a laser, or people who are welding, or there is something associated with an eclipse also. Please realize that when you move from extreme dark to extreme bright, or a temporary extremely bright light, the level of intensity changes thousands of times. And so the pupils which are dilated to take in more amount of light at night, if they are suddenly exposed to an extremely bright light, thousands of times more intense, then the amount of bleaching that takes place as far as the rhodopsin is concerned is extremely high, and naturally it is very likely that it will never come back to its normal level, and these rods and cones might be permanently damaged. And so lasers, something that we will discuss in detail sometime later on, have an extremely high intensity, and so even a temporary exposure to laser beam directly is going to permanently damage that particular spot or an area on your retina, and then you would not be able to see very clearly at that point. If there is a welding going on, that arc, electric arc that we talked of long back because of those excited atoms, is an extremely bright light, and that causes damage to your eyes, permanent damage. So they use a extremely thick dark glass when they are trying to do some welding. And then what about people who say that exposing yourself or looking at the sun during an eclipse is going to damage your eyes permanently? Let me clarify a few things, because there is a misconception about this. This damage issue happens specifically in situations where there is total eclipse and it's the motion of the planet is such that it's coming out of the total eclipse, and at that instant prior in the total eclipse, your pupils, because of the dark area, have dilated to a large extent. You are looking at the sun, which is nothing but a black disk, and suddenly at the corner, at the edge where the eclipse touching point clears off, the intensity of light increases millions of times. Through a dilated pupil, this extremely bright sunlight is going to permanently damage your retina, and if you keep looking, there is no chance of its recovering again. It will take time, but that's exactly what happens when you look at a blinding flash. If you look at a flash that is extremely bright, for a few seconds after that you can see nothing. In fact, in quite a few times, for a long time. That's because the whole system has been bleached and there is no time for it to recover back again. And this is the blinding light that is talked of. So we need to take care, we need to ensure that our retina does not get permanently damaged. There could be other drawbacks also that arise in the whole process, but that's a part of discussing how the defects in eyes are to be talked of. That's something that we have to do sometime later. Today we have talked of the two aspects of trying to accommodate the eye and trying to adapt it. Adapt to bright and dark, and accommodate in terms of distances. But there are many other things that we must know about our beautiful eyes. If you have liked whatever I have said, please look up some pictures related to all this information, and tell your friends about this. Like and subscribe to this channel so that you get a notification as to when and where I am going to put up the next lecture related to some topic of a similar type. We need to talk of the defects that our eyes also have. For all that important part, sometime later, 15 days more. Till then, Namaskar.